And if you want more problems, you just ask me. I will give you more problems if you want to solve, because here I had given already the solution. But if you want to do analysis by yourself, and of course that's perfect, I will give you more problems. And or you can even make your own problems. You can write some, you can draw the circuit by yourself, and you can solve the problem. You can find the equation for the current or the voltage drop across certain device. So now this is the circuit. We have the capacitor and resistor and inductor. And here we have to write similarly the equation in time domain. The time domain is the same method we have to follow. So the current is flowing in this direction. So here the current is exiting in minus. So minus L times di of t divided by dt, and the voltage, initial voltage across initial voltage of the inductor always having the opposite polarity. So if the overall polarity is plus and minus like this, the initial voltage source of this inductor will become minus and plus. So this is for the capacitor. For the capacitor, it's going to be definitely minus, and we have the plus 1 divided by c integral of I of t dt plus Ri of t. So you can apply the Laplace transform. So then it will become S times I of S minus, that is the initial voltage. And similarly, you can minus, this is the initial voltage across the capacitor, and this is the initial voltage across the inductor. And this is the 1 divided by Cs. This is the voltage across the capacitor, 1 divided by Cs times I of S. So yeah, here the capacitance value is 1 divided by 2 farad or 0.5 farad. So that is what I had written here, 1 divided by Cs. This is the standard formula, I of S plus R times I of S. And we can apply the values. We know the values. L is equal to 1 Henry and VC is equal to 1 volt. You can see here the VC voltage across the capacitor is 1 volt, and the capacitance value is 1 divided by 2 farad, and the R value is 2 ohms. And we have the I of 0 plus, we have 0. So you can apply these values in this equation. Then the equation will becomes like this: S times I of S minus 1 divided by S plus 2 divided by S times I of S, and so on. Then you can take the I of S as a common, and similarly the equation will become like this. So the same like the previous where we had seen that just before. Yeah, here what we had done, similarly here we are taking the I of S as a common, and then we are taking this 5 plus S plus 4 by S, and then this will become like this. And then you want only I of S, so then this is going to the other side. So similarly the same technique, the same method you have to follow here. So I of S, after you take, you can rewrite the equation like this: 1 divided by S square plus 2S plus 2. So this one you can write again like this: 1 divided by the S square plus 2S plus 2. You can write like this: S plus 1 whole square plus 1. So here it's a little bit different. This is not like 1 divided by S plus A times S plus B. You see here the formula, the final equation is a little bit different here. 1 divided by S plus 1 whole square plus 1 square. So this is like a 1 plus S plus A square. So this is the format is different. So we have to use a different formula. So if you refer the Laplace table I had given you, so it looks like this. So B divided by B square plus S minus A whole square. So what is the formula for this? E to the power AT times sine of BT. This is the formula I had given here. So you can just simply apply this formula here. So now this is the final equation in the Laplace domain for the current value. Now you have to do the inverse Laplace transform. So that is, it becomes I of t is equal to e to the power minus t sine t, because here you can see a value is 1, b value is also 1, and this is the formula. The formula is, okay, so if you apply this, then this is the final equation of the current value in this circuit. So you find the equation in S domain and you find the current equation in time domain. Here what we have done is we have used some values for the resistors, capacitors and inductors.